Welcome to video lecturing on Sc II SEM mathematics. The topic total derivative and total differential. In the last video I have seen the definition of a total derivative and total differential. In that we studied three different cases also. Let us revise those three cases. In first case we have seen that if u is a function of both x and y and x and y are functions of t, that is u is a composite function of t. And second case is if u is a function of xy and both x and y are functions of two other variables r and s, that is x is a composite function of two variables x and r and s. And third case is differentiation of implicit function, that is here in this case if u is a function of xy and it is not expressed in terms of any other variables, it is equal to some constant, an implicit function. So these different three cases we have seen in the last video. Let us take some examples on these. First let us start with the first case. Let us take one example in this. If u is equals to x square plus y square, where x is equals to e raised to t cos t, y is equals to e raised to t sin t, then find the total derivative of this one. Then in this find total derivative. Let us take here u is equals to x square plus y square, where x and y are given like this. See here in this case u is function of xy and x and y are in terms of t. Then this implies here u is a composite function of t. Therefore the required total derivative is given here as du by dt is equals to dou u by dou x into dx by dt plus dou u by dou y into dy by dt. It is equals to du by dt is equals to dou u by dou x. Here u is given x square plus y square, so dou u by dou x is 2x into dx by dt. Here x is given, x is equals to e raised to t cos t. So dx by dt means you have to differentiate this one with respect to t. Here it is product of two functions. It is first function and this one is the second function. So we can take here first function as it is, e raised to t as it is, into derivative of cos t is minus sin t, plus cos t as it is, derivative of e raised to t is e raised to t only, plus dou u by dou y is 2y, because differentiating u partially with respect to y. Here x is constant, derivative of y square is 2y into du by this is dy by dt, it is not u, it is y, dy by dt. So again here also you have to differentiate this y with respect to t. It is product of two functions. So again first function you have to apply product rule here. First function e raised to t as it is, this is e raised to t as it is, derivative of second sin t is cos t, plus sin t as it is, derivative of e raised to t is e raised to t only. Let us simplify this. So here all the terms contains 2 common, let us take 2, and e raised to t is also common, we can take this one also outside. Write the remaining terms, x into this minus sin t plus cos t, then plus here y into this is the sin t plus cos t. It is equal to substitute the value of x and y in this. This is 2 e raised to t as it is, x equals to we know e raised to t cos t into this bracket as it is, plus y is e raised to t sin t into bracket this as it is. Let us simplify this 2 e raised to t as it is, open this bracket, minus e raised to t cos t into sin t plus e raised to t into cos square t, plus here e raised to t into sin square t plus e raised to t into sin t into cos t. So these are opposite signs, plus and minus, they get cancelled. Write the remaining terms. Again in these two terms e raised to t is common, let us take it common. Write the remaining terms, this is cos square t plus sin square t. So it is equals to 2 into e raised to t. We know cos square plus sin square theta is 1, so it is into 1. So therefore this implies here du by dt is equals to 2 into e raised to 2t, because you know here e raised to t into e raised to t, this we know, this is e raised to t into e raised to t is equals to, we know, e raised to t whole square. It is nothing but here, it is nothing but e raised to 2t, we know a raised to m whole raised to n is a raised to m into n. So this is the solution, this is the total derivative of this u with given x and y in terms of t. This is the first case we studied. Let us take one more example. So that is, if z is equals to f of uv and uv is e raised to x sin y, v is e raised to x cos y, such then show that dou z by dou x whole square plus dou z by dou y whole square is equals to e raised to 2x into dou z by dou u whole square plus dou z by dou v whole square, and second one is sin y dou z by dou x plus cos y dou z by dou y is equals to e raised to x into dou z by dou x. First write the given data here. Given z in terms of f of uv, where u and v are given like this. See here, this is the special case 2, here it is. So here z is in terms of uv and uv are in terms of xy. Then this implies here z is in terms of x and y. This is the second special case of total derivative. Therefore here we apply chain rule here. Therefore by chain rule we have, this is we have studied in the last video also about this chain rule. I have given the formula of chain rule. So here z is in terms of uv, u and v are in terms of xy. So this implies here dou z by dou x, composite function again it is, dou z by dou x is equals to, first with respect to u, dou z by dou u into dou u by dou x, plus z is in terms of v, so it is dou z by dou v into dou v by dou x. And this implies, let us simplify this. This implies here dou z by dou u keep as it is because we don't have any equation for this, into dou u by dou x. Here u is given e raised to x sin y, dou u by dou x means here sin y have to treat constant as it is, derivative of e raised to x is e raised to x. Then plus dou z by dou v as it is, then dou v by dou x. Dou v by dou x is again here you have to treat cos y constant as it is, and derivative of e raised to x is e raised to x. So it is e raised to x into cos y. Then now dou z by dou y is equals to, this is equals to again same chain rule, dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. This you have to remember this formula, and it is equals to dou z by dou u keep as it is, dou u by dou y. Here dou u by dou y is e raised to x is you have to treat constant, derivative of sin y is cos y. That is like this, here e raised to x cos y plus dou v by dou y into dou u by dou y. Again dou u by dou y is e raised to x as it is, derivative of cos y is minus sin y. So it is e minus e raised to x sin y. That is here dou z by dou x is equals to, dou z by dou x is, dou z by dou x is equals to, you take here e raised to x is common in these two. Let us take e raised to x common, then add the remaining terms, sin y into dou z by dou u plus cos y into dou z by dou v. Take this one as equation number 1, and in this second dou z by dou y you have to take here e raised to x again common, add the remaining terms, cos y dou z by dou u minus sin y dou z by dou v. Take this one as second equation. So now we want to find here, we want to find dou z by dou x whole square plus dou z by dou y whole square. Let us squaring and adding these two equations. So we get here LHS are like this is equals to square this RHS also, e raised to x whole square, and this is sin y dou z by dou u plus cos y dou z by dou v whole square, and plus second also you have to write as it is. Let us expand this. This is e raised to x whole square is e raised to 2x into, this is a plus b whole square, that is sin square y dou z by dou u whole square plus cos square y dou z by dou v whole square, then plus this is 2ab, 2 into sin y into cos y dou z by dou u into dou z by dou v, and it is plus the second term also you have to expand like that only, e raised to 2x into, this is cos square y dou z by dou u whole square, then plus a minus b whole square you have to expand here, plus sin square y dou z by dou v whole square minus 2ab, that is minus 2 cos y into sin y dou z by dou u into dou z by dou v. So these two are plus and minus, I will cancel here, and same terms, and in these two terms again e raised to 2x is common, we can take it common, write the remaining terms, you have to add. So you have to add means here dou z by dou u whole square and dou z by dou u whole square is there. Let us take it common, write the remaining terms, sin square y plus cos square y, and in these two terms dou z by dou u whole square is common, I will take it common, cos square y plus sin square y remains. So this implies here dou z by dou x whole square plus dou z by dou y whole square is equals to e raised to 2x into this dou z by dou u whole square, and this is 1 plus dou z by dou v whole square, and it is also 1. This implies here dou z by dou x whole square plus dou z by dou whole square is equals to e raised to 2x into dou z by dou u whole square plus dou z by dou v whole square. This is the result we have proved first one. Let us prove second one. So for the second one, what we want here, we have to multiply dou z by dou x with sin y, that is equation, multiplying equation 1 with sin y and equation 2 with cos y, you will get this result. Let us consider this one. So let us consider here sin y into dou z by dou x. From equation 1 you substitute the value of dou z by dou x. So equation 1 is like this. Equation 1 you have to substitute. So in place of dou z by dou x, you have to substitute this one here. So it is equals to sin y into e raised to x into sin y dou z by dou u plus cos y into dou z by dou y v plus cos y as it is, and in place of dou z by dou y you have to substitute this one value from equation. Let us take one more example. If x to the power of 2 by 3 plus y to the power of 2 by 3 is equals to a to the power of 2 by 3, then show that dy by dx is equals to minus y by x whole to the power of 1 by 3. Let us take this f, this one as f of xy is equals to x to the power of 2 by 3 plus y to the power of 2 by 3 minus a to the power of 2 by 3 is equals to 0. So here this is an implicit function. Therefore here, since f is an implicit function, then by the rule of differentiation of implicit function, we have here dy by dx is equals to minus fx by fy, that is dou f by this is dou f by dou x divided by dou f by dou y. It is equals to dy by dx is equals to, here differentiating f partially with respect to x. So it is derivative of x to the power of 2 by 3 is 2 by 3 into x to the power of 2 by 3 minus 1, and y and a are constant, so its derivative is 0. Divided by dou f by dou y is derivative of x to the power of 2 by 3 is 0. It is derivative of 2 by y to the power of 2 by 3 is 2 by 3 into y to the power of 2 by 3 minus 1. So 2 by 3 get cancelled. It is equals to, here this is equals to minus x to the power of minus 1 by 3, 2 by 3 minus 1 is minus 1 by 3 divided by y to the power of minus 1 by 3. Take a reciprocal of these two. This is take this one in numerator, it is y to the power of 1 by 3, and this is in the denominator, it becomes positive x to the power of 1 by 3. So this implies here dy by dx is equals to, dy by dx equals to, both are having the same powers. We can take this one as here y by x raised to 1 by 3.